Today, we are going to break down for Agentic AI security in a deep level approach. As of 2026, the mainstream of generative AI has fully shifted from chat-based systems that return text to Agentic AI. Autonomous agents that directly control the user's PC environment and intervene at runtime to complete tasks. Autonomous agent systems like OpenClaw have surged in this space, but since these agents are predicating on executing autonomous tasks without user intervention, they inherently require elevated ecosystem privilege from the outset. They carry back bad security vulnerabilities and operational compatibility baked into their design. The first is security uncertainty. Your fully consistent takeover, credential theft, as well as the expansion into cloud infrastructure. The second is cost uncertainty. If looks for the building and unpredictable usage pipes. So what do technically sophisticated users do today? The best defense that technically proficient users currently attempt is provisioning a separate VPS and manually designing bridge networks and sandboxes. However, this is merely a stopgap measure to cover up structural flaws. Even with VPS isolation, you are only leaving less variance. You are leaving a critical residual risk. The root problem lies in the architecture itself, handing the agent the key system to OS level execution. Manual design VPS environment with bridge networks and sandboxes minimize the probability of directly damaging local machine. But the fundamental issue that the agent still holds OS execution privilege remains totally unresolved. Inside the VPS, sandbox escapes, credential leakage, and lateral movement into the cloud infrastructure are still possible. What enterprises and professionals fear most is their risks. Unpredictable agents are not production intelligence. They are dangerous toys. The adoption of Agentic AI is no longer just about securing autonomy, but rather about how perfectly we can control and isolate that autonomy. Let's be precise about what we are dealing with. A system-level agent, any agent that holds Cisco privilege, is simultaneously exposed from 5 directions. Sandbox escapes through misconfigured bounds or simply breaks conditions, has traversers that lets the agent work outside its intent directly. Credential theft because config files like END are sitting right there over space. And privilege escalation, where a container with process can affect the whole file system. And resource exhaustion, if it looks like drain CPU disk in your billing accounts. What makes this particularly dangerous is that these vulnerabilities will operate in isolation. Credential theft doesn't just mean a stolen API key. Once credential theft occurs, the damage escapes the local environment entirely and spreads through and losing the entire cloud infrastructure. From a zero trust perspective, the foundation of modern security architecture and structure of system-native agents maintaining persistent highly privilege represents a clear violation of principles and security vulnerability. This lack of greater access control for individual tasks undermines the effectiveness of the principle of least privilege. The chain of damage is architecture, not incident. To understand why this problem is so big, you need to understand what actually happens when an AI agent runs a command. There are 2 paths an agent can take. The first is external process paths. Shell commands like cat, rm, or git styled as child processes. And the second is the runtime direct control. System level APIs like fs read file called directly from the runtime. These look different on the surface but follow either path for enough, and they converge at exactly the same place. The kernel system layer. Both routes pass through libc on the window. This is the core insight. The architecture of directly granting an agent or consistent privilege is itself the most costly file system damage risks. It doesn't matter how you want this. The destination is the same. If your logic filters fail, through hallucination, wrong projection, or simple misconfiguration, the rest is directly in the line of fire. So what does a general different approach look like? The turning point of Pi security design is straightforward. While system-level agents follow a model of grant deep-level privilege first, filter afterward, I never grant those privileges in the first place. I have some file write permissions. It cannot remove your root directory in files. It cannot use your credit card information without any consent unlike other agents. There's no filter required. The privilege path simply does not exist. This isn't a policy constraint, it's a structural. The difference matters enormously when you're thinking about what an attacker or malfunctioning model can actually do. Pi doesn't receive a key or authority to walk into file system. It observes exclusively into the user's interface framework level and understands the context. The Accessibility API is an officially supported voice channel that delivers data for this current data. It does not directly manage files. It reads what the application is currently running. This is a precise technical distinction that policy constraint from structural. System-level agents are like being handed your private key and doing tasks autonomously itself. Pi is like a highly intelligent but trustworthy subordinate who has no authority to search through your private cabinet. The workflow's common system remains directly and physically unreachable. Let's put this in concrete terms across the dimensions of that. On architecture, system-level agents are tightly coupled to the operating system. Lower-level common calls direct particular access. Pi operates through an UI interface proxy at the application layer. On file system access, system-level agents have direct read-write permission. Pi has 0. No direct file handle is ever open. On API key, system-level agents require users to manage their own measures, often stored in plain text. Pi is keyless and full managed service. Authentication is handled at infrastructure level. On custom audit, system-level agents expose users to pay as you go risk. A runaway loop remains a runaway bill. Pi uses a fixed subscription. Billing risk is outsourced by the service, not the user. On security configuration, system-level agents require manual setup. Files sent by design from this. Pi is full managed service. Pi security architecture built into the product. There's nothing to configure. And on final decision authority, system-level agents can act unilaterally. Pi requires explicit user approval at every critical decision point through the mandatory decision layer. Under the system-level agent, the user operates the agent while simultaneously serving as security module, building watchdog and system administrator. A tool that demands this much vigilance does not raise productivity. It raises cognitive overhead. Pi's answer is structure, not procedure. Privileges are physically strict at the design side. Costs are fixed at the subscription level, which judgment is embedded into the product itself through the mandatory decision layer. There are no variables left for the users to manage. And in 2026, that is exactly what users, enterprises, and professionals demand from Agentic AI. Not unbounded autonomy, but true reliable control. The sense of unpredictable variables that predictability is the most profitable for securing hyperplex. The question was never whether AI agents are perfect. They are clear or. The question is whether the architecture underneath them deserves the trust we are placing. Thanks for watching.